We present an approach that jointly embeds 3D shapes and occluding contours to handle for sketch-based 3D modeling and manipulation problem. We first train a variational autoencoder network, VAE for short, on occluding contours dataset generated by non-photorealistic rendering algorithm. The VAE consists of an encoder with 4 convolutional layers to encode input occluding contour to a 128 dimensions latent vector, and a decoder with 4 convolutional layers to decode the latent vector to a sketch similar to the input contour. In this way, we obtain a space in which each point is a latent vector that represents a certain occluding contour. After that, we train a volumetric autoencoder to establish the relationship between 3D shapes and the embedding space. The volumetric autoencoder has 3 convolutional layers in the encoder to encode 3D voxel to a 384 vector and 3 convolutional layers in the decoder to reconstruct a voxel of the input 3D shape. The encoded 384 vector is related to the latent vectors on the embedding space that represents the front, top and left view of the input 3D shape. This is implemented by employing a supervised training. With the joint embedding space of 3D shapes and 2D occluding contours, one can model 3D shape with an input sketch by first encode it to latent vector and find the nearest latent vector on the embedding space with the data from our dataset. By simply using the latent vector of the input to replace the nearest latent vector, and combine with its other 2 views latent vectors, a 3D shape has similar occluding contours as the input sketch can be generated by volumetric decoder. Given a 3D shape, volumetric encoder can generate 3 latent vectors represent 3 views of its 3D voxel. By searching latent vectors from our dataset on the embedding space similar to a certain view of the 3D voxel, we can replace it to generate a modified shape with volumetric decoder. We show more results of the 3D modeling and manipulation by our method. We show the shape manipulation results generated by occluding contours.